Okay, great. My name is Bryce, CGT class of 27.
I'm Aaron, DMD and CGT 26.
I'm Amy, DMD and CGT 26.
I'm Anya, CGT 27.
And we're here to talk about a brand new way of remastering your favorite games. Old OpenGL games are visually iconic, but they were made under the limitations of 1990s rendering technology, tackling challenges such as the fixed function OpenGL API and strict hardware limitations. But what if these games are rendered today with more up-to-date techniques, such as real-time path tracing, modern lighting, and dynamic shadows? And what if the process didn't involve recreating the games from the ground up? Introducing glRemix, a DirectX 12-powered platform for remastering old OpenGL games and applications with modern graphics and asset replacement, all without modding or source code access. To do this, we replace the system OpenGL.dll file in the hostapps.exe location. This causes all of its calls to the OpenGL API to be intercepted by our shim layer. These commands are then written to shared memory, where they are then consumed, interpreted, and executed by our DXR application, effectively recreating scenes ray traced in real time. Now, before we show you just how easy it is to use glRemix, I'm going to pass it over to Aaron, who's going to show you what glRemix is capable of.
Yeah, so glRemix works with multiple pre-programmable shader era OpenGL applications. And so on this slide here, we have three comparison images. So in each of these on the left, we have the original application without glRemix, so in its original form. And then on the right, we have the visual result after we run it with glRemix. And so in all of these examples, we can see that the lighting has totally transformed in all of the graphics, thanks to the full path tracing that we have in our render. glRemix also works with closed source commercial games as well, such as PC Gamer's best game of all time, Half-Life from 1998. So here's an example of an outdoor scene from that game running with glRemix. And then here's another example, but with an indoor scene. And it's one thing for us to show you a bunch of screenshots, but how about we show you a live demo of glRemix with a copy of Half-Life? And so first thing we're going to do is we're going to open the game without glRemix as is. Just to give you a reference of what it looks like normally. So this is the game in its glorious 1998 state. And now we're going to drop in our glRemix runtime files in the directory of the executable, and then we're going to open the game again. And we can see that once our debug window has opened, we can see that glRemix has successfully initialized, and the graphics are now totally different. Everything is fully path traced, and we can still run around in the game and play it as is and interact with the NPCs and blow up the microwave casserole.
Yeah, so going into some of our features. So first off, we have the render. Obviously, we have path tracing, which is pretty cool. We have direct lighting and shadows that we have in our DX12 shader. We also have texturing along with mip mapping, which is pretty important since a lot of these old games use a lot of textures to shade their meshes. And we also have environment mapping. Another thing we have is materials. So we actually have a toggle that the users can specify if they want a mesh to be a mirror, and this just shows off the visual aspects of our path tracer. We also have asset replacement. So through the im GUI, we pass in a list of all the assets to the user, and they could essentially just choose one. They could toggle visibility just to make sure they have the correct one. And then all you have to do is put in the GLTF file and it gets replaced right there in the scene.
And for performance improvements on the GPU side, it can be highlighted by implementing parallel bottom level acceleration structures, aka BLAS, as well as bindless rendering via the newest shading model. And on the CPU side, we focus on double buffering the IPC data transfer from 32-bit to 64-bit, as well as achieving speed of light, NVIDIA term, aka all of one data transfer. For the future, we want to add support for more mesh importing options through OpenUSD, as well as increasing or hashing heuristics to make sure that all types of OpenGL old games are supported, as well as just general rendering fidelity, the most important of which will be denoising through DL assets. So thank you everyone for listening, and we hope that you can see the power of glRemix.
Amazing, guys. I'll open it up for any questions from the classroom, and I'll ask anybody on online to raise their hands, and we can come to you as well. Is there any questions from the class? Leonard, I knew you would be having. Go for it.
I have one question about the IPC. So you have a second process that does the render, or you don't?
Yes, so the thing about these old games are that they would all be in 32-bit. So yes, we would need to transfer to a 64-bit process because the X12 is only 64-bit. Yes.
Do you have a second process that sends back the image, or do you just spawn in a window in the process that does the rendering?
We do it within the host window.
I see.
Yes.
Okay.
We were talking about like asset replacement, and I'm wondering like what you kind of currently do for getting the lighting from the scene, and something I'd be curious about if you would be adding would be that given that the lighting for like a scene, like a level in Half-Life, for instance, is not designed with this sort of ray trace view in mind, and you can kind of see in some of the examples that comes out pretty dark, like what sort of options you could enable in order to like make it in real time adjust the scene in order to like have a better view.
I can take it. Yeah. So, yeah, future work could involve adding sort of like scene graph functionality. It'll be a very easy process of allowing the user to add lights dynamically to the scene anytime they want to. OpenGL fixed function has only 8 lights, if you can believe that, hard limit. So as you can see, like a lot of these old games had sort of light maps baked into a lot of the textures and stuff. With actual lighting, you can see how dark some of them get, but adding sort of lights on the fly shouldn't be an issue if we wanted to go that direction. That's another question.
You mentioned like after usage or the whole game will be renders in the pathways. How do you handle the difference between materials and light source when you're switching the render?
So
If you don't mind, can you repeat the question? I don't think the audio caught.
yeah, so the question was how do we I think handle lights when we go from GL to glRemix. So in our current implementation, we use the API lights. So in OpenGL 1 or fixed function OpenGL, you, as previously stated, there's like 8 dynamic lights you can specify, and so those can be like point or directional lights, and we support those. So if there was a such light specified in the original host application, that will also be reflected in our render.
Any other questions? I'm not seeing anything on chat, so great work, guys, really inspiring, and yeah, hopefully this gets pulled by other people who might be doing similar things with all the GL games. So great work.
All right, thank you.
Thank you.